Anyway, what's up guys, and it's great to be back here again for this video. We're going to talk about a topic today called implicit differentiation, and I'm going to try my best to help you. I'm going to try to help you understand this topic well. Okay, so let's quickly just cut to the chase. There are functions that we write explicitly in terms of x. So what do I mean? Y equals x squared, for example. You can see that you have a y equals some stuff with x on the right, or for example, y equals 6x minus sine x. You see that there's y on the left side and you have x's on the right. So you write here y explicitly as a function of x. Now, if I want to find my derivative of this, all I do is I bring down the 2, I use it to multiply the number in front of the y, which is an invisible 1. So 2 times 1 is 2, and then x, and then I just subtract the power, or subtract 1 from the power. That's 2 minus 1, which is a 1, which is just basically 2x. And I apply the same process here. To differentiate this, I differentiate 6x, which is 6, minus, when I find the derivative of sine x, I get cosine x. Okay? So we have these very nice smiley examples here. Now, there are functions that are not like this. A lot of functions are not like this in reality. You have functions where it's either awkward or impossible to write y explicitly as a function of x. So y is implicitly defined in x. So this is where we apply the concept of implicit differentiation whenever we want to find the derivatives of such functions. So let me give an example. I know I just said stuff that may be beyond you right now, but let's give an example. So let's say I have something like this: 6x minus y squared equals 4y plus x cubed. Okay? In this particular case, it's not so easy, or arguably impossible to write y explicitly. So for you to write y, just y here and x's on the other side. So this is an example of an implicitly defined function. And we are given the task of finding the derivative of this guy. That's dy dx. Okay? How do we go about and do? Let's put an emoji there. How do we do dy dx? So the thing we have to do, the first way to tackle and the best way to tackle problems like this is to find the derivatives of both sides with respect to x. So I'm going to differentiate the left-hand side with respect to x, and I'm going to differentiate the right-hand side with respect to x. Okay? Because the left is equal to the right, if I differentiate the left-hand side with respect to x, it has to equal the derivative of the right-hand side with respect to x. Okay? So differentiate both sides. So let's do that. Now let me erase this smiley emoji that's not all up in the way. Okay, so this question mark here. So I'm going to differentiate each side. So when I find the derivative of the left-hand side, start with 6x. When I differentiate that, I get a 6 minus. When I differentiate y squared, the way I do this is you use the chain rule. So y is some function in x, some complicated function, right? And whenever you have a function raised to a power, if you use the chain rule, you differentiate this as if it's an entity on its own. So I differentiate y squared normally. I treat this as if it's a single letter. So that's 2y, right? Like I did here, 2x. But I have to multiply my answer by the derivative of the function that's on the inside. Now, the function that's on the inside is just y. It's not x, it's y, which is some complicated function of x. So I have to write dy. Does that make sense? So that's the chain rule here. So equals to 4. I'm differentiating the right-hand side. Now, I just have a y. When I differentiate y, it's just y x. Okay? Whenever you see a y, just write dy dx if you're differentiating, because you're differentiating a complicated function of x, which is y, with respect to x. So you just write your dy dx plus x cubed. When you differentiate, you get a what? Squared. Okay? So you have that 6 minus 2y dy dx equals 4 dy dx plus 9x squared. Okay, hope that makes sense. Now, what do you do from here? Save this and see if I can scroll down. What do you do from here? what you have to do is, our ultimate goal is to find dy dx, so you bring all the dy dx terms together. So I can bring those to the right, and I can bring all the other terms to the left. So I have 6, if I bring out the other term, minus 9x squared equals 4 dy dx plus 2y dy dx. Okay, now dy dx is common, so I can just factor it out. So I just have 4 plus 2y, then I have a dy dx, then I have equals 6 minus 9x squared. Okay, I'm almost done. So what I need to do at this particular stage is to make dy dx the subject of the formula. So you just write dy dx equals 6 minus 9x squared over 4 plus 2y. Okay, and that's all I need to do. So that's the answer to this problem. Okay, you will notice that dy dx has both y and x's in it. Okay, and that's just the case for this particular function. Okay, so I hope this example was clear. Let's do another example here. Let's go to number 2. I'm going to come up with this one in my head. Let's do 2x squared minus 4xy equals 9y cubed plus 6x squared y. Okay, so this is some complicated function of y and x, and we want to find the derivative of this behavior, this function. So what do we do? Same process. You differentiate both sides with respect to x. So I differentiate the left-hand side, and then I differentiate the right-hand side. Let's differentiate the left-hand. To differentiate the left-hand side, what do I do? Take each term. So when I differentiate 2x squared, I get what? I get 4x minus, okay? I have 4xy, which is a product of two things, 4x and y. So let me just write that by the side here. So I have 4xy, okay? I am going to differentiate this term using the product rule. When you have a product of two things, call this your u, and your differentiation is basically ud plus. That's the product rule, okay? If you don't know the product rule, maybe I'll teach it in another video, but basically it's this. If you have a product of two things and you want to find the derivative, take the first function, multiply by the derivative of the second, that's u times the derivative of v, plus you take the second function v and multiply by the derivative of v. So in that particular case here, let's put a parenthesis here just so that we won't get everything confused. I'm going to put a closing parenthesis here. So minus, open brackets, u is 4x times the derivative of y is just dy dx. Again, y is some complicated function of x we don't know. When we find the derivative, we write dy dx plus, okay, y times, what's the derivative of 4x? 4. Okay, so that's all you need. So that equals, I've done the left-hand side, now time for the right-hand side. 9y cubed. If I differentiate this, I get 27 y squared. According to the chain rule, treat y as if it's a single letter or a single thing. 27y squared. Then I multiply my answer by the derivative of this guy, which is what? Y. Okay, that's that guy here. Now plus. Okay, plus. Let me just adjust my pen size. Research. That's it. I can erase things very quickly. Plus 6x squared y. Now, this is another product of 6x squared and y. Okay, so I use the product rule. Let's call this u and v, which is u dv plus vd. So let me just write that here. Plus, open a brackets or parenthesis. U dv is 6x squared, which is my u function, times the derivative of y is just dy dx, plus dy times du is what? 12x, okay? When I differentiate 6x squared, I get 12x. I hope that makes sense. So we have a long thing here. So let's just expand this. On the left-hand side, we have 4x minus 4x dy dx plus 4y equals 27y squared y dx plus 6x squared dy dx, 6x squared dy dx plus 12y. Okay, So I have this long function. So I'm almost done. All I need to do is just bring out all the dy dx's together. So I can move all the dy dx terms to the right and bring all the other terms to the left. It does not matter. I could have done it the other way as well. But let me just bring all the dy dx terms to the right. I just feel like doing it like that. So I have 27y squared plus 6x squared plus, if I take the minus 4x, it becomes a plus 4x. Okay? Everything here is multiplied by what? Y dx. So I just took out the dy dx, 27y squared, 6x squared, and 4x. I just factored out the dy dx. Now, on the other side, I just have what? 4x, that's this guy, plus 4y, that's that guy, minus what? Minus 12xy. Okay? So I make dy dx the subject of the formula. So dy dx is 27y squared plus 6x squared plus 4x divided by 4x plus 4y minus 12xy. Okay? I hope that makes sense. So that is it for that problem. We're going to do one more problem. I'm going to try and introduce a sine and cosine or maybe a natural log there just so that you can see how it works. Okay? So problem 3, and I think we'll conclude with this problem. So I just want to give you an introduction on how to do these types of problems. Maybe, I'm still trying to debate, maybe we'll do more problems with this later on, maybe. So let's do one more question, which I'm going to come up with in my head. X cos y plus y squared equals x ln x minus x squared. Okay? So or let me just change one of these letters to let me make this ln y. Okay, so you have some function like this and we want to find the derivative. It looks scary, but it's not scary. Okay, so we're going to take the derivative of both sides with respect to x. So we're going to find the derivative of the left hand side. Now the first thing I encounter here is a product of two things. Okay, and we use the product rule. X cos y, this is my u and this is my v, so we're just going to use u dv plus v du. So what do we have here? So we have u is x times, when we take the derivative of cosine, get a negative sine y, okay? Negative sine y, but because this is a function of x, a complicated function of x, according to the chain rule, differentiate the outer function, then we multiply this by the derivative of y, which is what? Y dx, okay? For my brackets, plus is cos y, and when you find the derivative of x, you just get a 1. Okay, so that's the first guy done and dusted. So next thing is 2y. We're going to differentiate y squared. We get 2y times the derivative of the inner function dy dx. So I'm done with my left hand side. Equals, so I'm just going to write the right hand side here. Again, another product. I have a product of x and ln of y. Okay, so let's just write that here. This is my u and this is my v. So I'm going to do u dv plus v du, and my u is x. Now my derivative of ln, the derivative of natural log is 1 over y. But according to the chain rule, because I have a y here, I'm going to multiply that by what? dy dx, okay? Plus, sorry, in case everything in brackets because it's the product rule. So I just have ln y, which is my v, times the derivative of x, which is a 1, okay? That is it. Minus, when I find the derivative of x squared, I just get 2x. So let's open everything. So on the left-hand side, you have minus x sine y dy dx plus cosine y plus 2y dy dx equals, on the right-hand side, you have x over y dy dx plus ln y minus 2x. So what do I do at this stage? Just bring up together all the dy dx's to one side. Let's take everything to the left. So the dy dx is to the left. So I have minus x sine y, okay, plus 2y minus x over y. I open a parenthesis, have dy dx. So this here, and when I bring this over, it becomes a minus. Then on the right-hand side, I have ln y minus 2x minus what? Cosine y. ln y minus 2x minus cosine y. So my dy dx is ln y minus 2x minus cosine y over minus x sine y plus 2y x. I can leave it like this, or if I want to, I can multiply both the top and the bottom by y, just so that I don't have a over y here. So I'm going to multiply everything through y on the top and bottom. So what do we have here? We have y ln y minus 2xy minus y cos y over minus xy sine y plus 2y squared minus x. Okay? So that is the correct answer. So don't worry about what I did. I just added a y here, top and bottom. I've not really changed the fraction. You can leave it like this if you want, but I just wanted it to look a bit cuter. That's all. Okay? So that's the answer to this problem. I hope this was beneficial to you. I just had to do a quick video on this. I hope you understand that it's not too strange for you. If you have any comments about this, please let me know in the comment section. Thank you very much. It was great to do this video, and enjoy the rest of your day, your week, your month, your night, whatever situation you're in now. Take care, pleasure, and all the best. Bye.